Hello everyone, we are Team DNA Awesome from SMU Hijitsin. I am Yi. Due to the emergence of COVID-19, face mask has become an essential personal protective equipment in our daily life. They are the one item we now know help to stop the spread of COVID-19. However, the mass production and the use of disposable face masks have led to significant environmental issues. Around the world, 129 billion of face masks are used every single month and 3 million are thrown out every single year. Most of them are made up of layers of plastic microfibers. It's creating a new kind of plastic pollution, contaminating water waste and hurting wildlife. This results in generation of millions of tons of plastic waste and widespread pollution. Improper disposal of face masks further exacerbates the problem, as face masks made up of plastic microfibers will decompose and release hazardous fumes and chemicals that harm the environment and life on our Mother Earth. It's not about the fact that face masks are not biodegradable or recyclable. It's about the fact that masks are hazardous to our wildlife, not just because they can eat the mask, but also animals get entangled in the straps of masks. Existing solution to this issue are cleaning campaign, but as we know, cleaning campaign is lack of sustainability. But no worries, we're introducing you RenewMask. RenewMask is an eco-friendly mask recycling system that collects and recycles face masks for medical and home use. The recycling system produces plastic fibers that can be reused in the production of other plastic products like 3D printing filament.
RenewMask is strategically placed along busy streets, hospitals, clinics, houses, or schools to facilitate the collection of masks. RenewMask consists of two parts: an upper part for mask collection and a lower part that processes masks into new plastic materials using heat.
In the upper part, a location sensor is incorporated to detect the placements of the bin and prevent theft. For aesthetic purposes, it is hidden under a board. It detects the location of RenewMask, sending the coordinates to the Arduino, which is then sent to the cloud and being shown in the app. As we plan to collaborate with MPSB in the collection of mask waste, these mechanisms allow them to plan their plastic fibers collection route. When a user approaches the cover at a limited distance, an infrared sensor (IR sensor) detects the presence of the mask and activates a motor to open the cover.
This mechanism prevents the direct contact with germy masks.
Next, an ultrasonic sensor is used to detect the volume left in the upper part. When the masks are accumulated to a certain amount in the upper part, the ultrasonic sensor will detect and trigger the servo motors to open the inner cover and therefore allow masks to fall into the lower part of the bin. The data is then sent to the ThinkSpeak through the Wi-Fi module. Finally, the data is shown in the app in the form of a graph. And now, as you can see, the graph shows that there's no mask. Now, I'm going to put some masks into the bin. As you can see now, the graph shows that certain amount of mask is inside the bin. Continue to add on some mask. Refresh the graph again, and you can see that the level of the mask increases. In the lower part of the bin, the masks are heated at their melting point. After carrying out the experiment, we found that the average melting point of mask is 170 degrees Celsius. However, to ensure a complete melting, we set up the temperature of heater to 200 degrees Celsius.
Once melted, the plastic is left solidified naturally at room temperature. To facilitate this process, a piece of iron is positioned above the heater to allow the conduction of heat to the iron. As the mask fall on the piece of iron, they receive heat and begin to melt. A timer will notify the user that the process is complete, indicating that the solidified plastic is ready to be retrieved from the bin. To prevent overheating and potential hazards, a fan is installed within the system to remove excess heat and maintain a safe operating temperature. A product of this process is a plastic materials that can be used in production of various other plastic products. For example, the filaments used in 3D printings, plastic boards, and plastic chairs.
We aim to establish a collaborative partnership with Malaysian government to implement and distribute our project across the entire country. By doing so, we envision creating a sustainable, responsible, and clean community in Malaysia. Additionally, we plan to forge alliances with prominent plastic companies in Malaysia, such as DHM Plastic Industry in Bukit Tambun, iconic Medicare Glove Factory in Batagawan, which is involved in mass production. Our intention is to sell the plastic materials produced by RenewMask to these companies, fostering a circular economy and supporting the local industries. Furthermore, we tend to increase the capacity of RenewMask. We would like to also implement the UV rays, solar panel, and ESP32 can into our project.
In conclusion, RenewMask presents a groundbreaking solution to the environmental challenges posed by disposable face masks. By transforming masks into useful materials, RenewMask can address the issue of plastic pollution and contribute to sustainable development goals. With a user-friendly design and wide distribution, RenewMask empowers individuals and communities to play an active role in mitigating the pandemic waste.
RenewMask is not just a solution, it is a catalyst for change, fostering a greener future and leaving our planet a positive impact. RenewMask, be clean, be safe, be healthy. Thank you.